Okay, now we're moving on to doing quadratics in what's called vertex form. So first off, just a little bit of a review. Determine the slope and the y-intercept. Well, remember our slope is here and our y-intercept is here. So m is negative 2/3 and b is 8. Solve by completing the square. Well, we move the 4 over, we leave a space. Then we take half of, oops, that's negative 8. Good catch, because I have to take half of negative 8, which is negative 4. I remember the little cheat, I can just put this, and I know where I'm going. But now I'm going to square that, so I'm going to add 16 to both sides. That's going to give me 20 over here. Well, I have to square root, cancel. So I get x minus 4 equals plus or minus. And over here, save space, this is really root 4 times root 5, 2 root 5. Now I move the 4 over, 4 plus or minus 2 root 5. So this is just a different form. And here it is. Y is equal to a times x minus h squared plus k. The vertex is going to be hk. And then for the axis of symmetry, x is going to be equal to h, which makes sense because h comma k is x comma y. And the axis of symmetry is whatever's in that x position. And since h is there, x will be your h. Now a, like before, if it's positive, it's a happy parabola. If a is negative, it's a sad parabola. If a is greater than 1, it's stretched vertically, so it's narrower, and if it's less than 1, it's wider. So let's move on. Identifying the vertex and the axis of symmetry. Remember, this is really x minus negative 4. That's important to remember, because the vertex is negative 4, negative 5. And the axis of symmetry is x equals negative 4. That's it. This 2, even though it's not asked for, the 2 means it's a happy parabola, a smile, and it's going to be thinner. Here, we have a plus 1 out here. So it's not going to be stretched, but it is going to be positive. Again, this is x minus negative 1. So my vertex is going to be a negative 1, comma, 8. And the axis of symmetry, once again, you just get it from that first spot. It's negative 1. X equals negative 1. Okay, the third example. We're not analyzing this, but just to think about it. It's going to be upside down, and it's going to be wider. My vertex is already right here in subtraction form. So that's going to be a 3, negative 4. And then my axis of symmetry is just going to be x equals 3. Okay, moving on. Determine the graph opens up or down, identify the vertex, determine its minimum, maximum, domain, and range. So, opens, 2/3 is positive, up. The vertex is going to be at negative 6, negative 1. Well, if it opens up, that means it has a minimum. Think about it. Right there, the lowest point. The axis of symmetry is going to be x equals negative 6. The domain, again, is going to be negative infinity to positive infinity. These normally are. The range, how low does it go? Negative 6 included, up to positive infinity. Next one. It's going to open down. Why? Because it is negative. The vertex, remember this is x minus negative 2. going to be a -2, -7. It's going to be a maximum because it's round. The axis of symmetry is x equals -2, just that first number, h. The domain, again, is going to be -infinity to positive infinity. That doesn't really change. The range, though, remember, when it's upside down, we put infinity first, negative infinity, because it's going down. How low does it go? How high does it go? -7 included. Last one here. It's going to open up because it's +1 out here. The vertex, remember, this is going to be x minus, sorry, don't know what happened there. X minus a -5. And really we have a +0 out here. It's not written, but it is. So my vertex is going to be a -5, 0. Since this is a happy parabola, it's going to be a minimum. Axis of symmetry is going to be -5. The domain, again, not really changing. And the range, how low does it go? Right there, 0, inclusive. How high does it go? Positive infinity. I did make a mistake. I don't know if anybody caught it yet. But the vertex on this first one is going to be -1. The y value, not the x value. Because it's over -6 and down to -1. So -1 is the range. And again, you can find the range from this number right here. Sorry about that. Okay, so solutions to quadratics are also called, we talked about this before, zeros, roots, or x-intercepts. If the parabola doesn't cross the x-axis, it's imaginary. So to graph each function, provide the following information. A total of 5 points must be graphed. So, open up or down? Up. What's the vertex? -2, -4. I can put that on right now. Maximum or minimum? Well, if it's opening up, it's going to have a minimum. Axis of symmetry, x equals -2. Don't went ahead of myself too far. This is x minus 2. This should be +2. My mistake. Sorry. So the axis of symmetry is at +2. So it's at 2, -4. My mistake. So that is where your axis of symmetry is going to be right here. So we have the point at 2, -4. Now notice it says total of 5 points. Let's make life easy again. Let's use our calculator. Okay? Take your graphing calculator, turn it on. Y equals, put in parentheses, x minus 2, parentheses, square it, -4, and graph. And then, let's look at the table. And there's some points, and some are off the chart, like the -212, right? It's off the chart. But we can put those on. So, -1,5. There's a point. And then on the flip side of that is going to be 5,5. It's a mirror image. So there's 3 points. Then let's get our roots. 0, 0, this is right off the calculator, and 4, 0. There's 5 points. And there is your graph. Domain. Again, this isn't changing. Negative to positive infinity. The range. How low does it go? -4, inclusive. How high does it go? Positive infinity. Zeros, same thing as roots. 0, 0, and 4, 0. Solutions, roots, same thing. Now notice, there are two real solutions. Like here and here, that's two of them. You could also have one solution. So like you have something like this and it looks like that. You could have one solution where it comes down and just touches it. And then we talk about imaginary where it could look like that and never crosses. So there's three possibilities of how many solutions you could have. Let's look at this one. Y equals -1/2. Well, the negative tells you it's going to open down. The vertex, remember this is x minus -5. So it's -5, 4. If it's going to be opening down, that's a maximum. The axis symmetry is at -5. Right there. The vertex is at -5, 4. The domain, negative infinity and positive infinity. You know that. The range, how low does it go? Negative infinity. How high does it go? 4, inclusive. Remember, this tells you the range right there. Zeros, let's use the calculator. So you put in your calculator, -1/2, parentheses, x plus 5, parentheses, squared, plus 4. And you hit graph. Okay, so I just entered it right there. The key point is, remember, when you're putting in negative, use the gray negative key, not the blue minus key. Then we hit graph. That's about where we said it should be, right? And we can verify that by looking here. Okay, and then we can just use these points to graph it. So I'll put some points on here. -7, 2. And -3, 2. And -5, 4, we already have that on there. And then like -10 is at -8.5, right there. And the other -8.5 is at 0, right here. And then we have if I actually make this look better, right there. Okay, so we're going to do that now. Where are my zeros? Again, I have two answers because it goes through two different spots. Now, if you notice on the calculator and on our graph, we can't really tell exactly where the zeros are. It's kind of just an approximation. We can learn how to use the calculator later to do this. There is a way to do it, but we're going to accept right now. If you notice here, it's between -7 and -8. Now we're just going to write that. Between -7 and -8. And then here it looks like it's between -2 and -3. And -2 and -3. And that's enough. That's all we have to say. Approximately where is the 0 on each of them. That's good enough. We will talk about the calculator later. And last but not least, before we move on, write each equation in vertex form from the quadratic form, standard form. So how do we do that? We move the constant to the other side. So we're going to have y plus 4 equals x squared plus 6x. Then get a 1 in front of the x term. Well, we have a 1. Okay? Right here. Then complete the square. So again, half of 6 looks backwards, but that's okay. X plus 3 squared. We're going to get 9 here and plus 9 here. So that's y plus 13 equals x plus 3 squared. And then get rid of the 13. So we have y equals x plus 3 squared minus 13. That is the exact same. Okay, this last one's a little bit tricky, and it's tricky because of this 2 right here. So we're going to start off the same way. We're going to move the 3 over, and we're going to have y minus 3 equals 2x squared minus 12x. Now what I'm going to do is, remember, it says you need a 1. So I'm going to actually pull the 2 out. Y minus 3 equals 2 x squared minus 12, sorry, I can divide, 6x. Now what I'm going to do is I'm going to complete the square just on this part. I'm going to come down here for room. So y minus 3, I'm going to leave a space here for what I'm going to do next. And this is a tricky one. So we have 2, and we have the x squared minus 6x. Now we're going to complete the square, so we're going to take half of this, just like we've been doing. And here's the cheat. Remember, that's nothing new. But now remember, we're going to square the negative 3 and add 9 here. But you have to think about the fact that it's really not 9, it's 18. So even though we're adding 9 there, we're adding 2 9s. So on this side, we're going to add 18. I know this is tricky. So that's going to be y plus 15. Now, we're going to move the 15 over by subtraction and get 2x minus 3 squared minus 15. And that's our final answer. And like I said, that's a kind of tricky one. Go back and look at it again. Take some time to process it. It's what we've been doing already. It's just that this 2